सो न्यूमेरिकल स्टार्ट करते हैं। पहला और दूसरा न्यूमेरिकल है। द बीटा गेन ऑफ द ट्रांजिस्टर सिग्निफाइज फर्स्ट एम्पलीफिकेशन कैपेबिलिटी ऑफ द ट्रांजिस्टर, सेकंड वन रेक्टिफिकेशन कैपेबिलिटी ऑफ द ट्रांजिस्टर, सी रेगुलेशन कैपेबिलिटी एंड लास्ट इज ऑल ऑफ द ऑप्शन आर करेक्ट। सो अगर आपको याद हो तो बीटा इज कॉमन इमीटर करंट गेन, that is beta is IC by IB. It shows that the IC equals to beta times IB. If IB is very less, then beta implies that the how much input current is amplified to the output. Clear hai yaar? So this beta shows the amplification capability. Is it okay? So for this question the correct answer is A. Now the second question, the correct relation between the alpha beta for a given transistor is, we have different option. Now we will solve it. IE is equals to IB plus IC. Clear? Now just to take IC common, then it is IB by IC plus 1. Now IE upon IC is 1 by alpha, then it is 1 by beta plus 1. So 1 by alpha equals to 1 plus beta. Clear यहाँ तक? From that we can write the alpha is equals to, here I just write alpha equals to beta 1 plus beta. Clear hai yaar? Now but they have given the relation in terms of beta. Okay, no problem. So just cross multiply alpha plus alpha beta equals to beta. So alpha equals to beta minus alpha beta. ठीक है? So just take beta common, so 1 minus alpha. So beta equals to here alpha, beta equals to alpha 1 minus alpha. Is it okay? Or we can say it is minus alpha minus 1. Clear? So we have two options. So let's check minus alpha minus 1. Minus alpha minus 1 is present, or alpha 1 minus alpha not present. Wrong, and it is wrong also. So for this question we have correct option as A. Clear है यहाँ तक? Second, so I hope so second question clear हो गया. Now next question देखते हैं. थर्ड और फोर्थ क्वेश्चन लेते हैं. इन ए बाइपोलर जंक्शन ट्रांजिस्टर द करंट गेन इन कॉमन इमीटर कॉन्फ़िगरेशन इज. ठीक है, सो सॉल्यूशन देखते हैं. इन कॉमन इमीटर द करंट गेन इज कॉल्ड बीटा एंड इट इज द रेशियो ऑफ द कलेक्टर करंट टू द बेस करंट. Since beta is IB is less due to the recombination, so beta is high. Now IC is high due to low recombination, so beta is high. So beta is greater than 1. Alpha is for common base and gamma is for common collector. Clear है? Now so हम check करते हैं option wise. IE upon IC it is wrong. IB upon IC it is just 1 by beta. It is 1 by beta. Now IC upon IB it is correct, and this IE upon IB it is gamma. It is gamma and it is 1 by अल्फा. सो इस क्वेश्चन का जो करेक्ट आंसर हो गया वो सी सही हो गया. नेक्स्ट क्वेश्चन, इन ए बाइपोलर जंक्शन ट्रांजिस्टर द करंट गेन बीटा, फर्स्ट ऑप्शन, डज नॉट चेंज विद द चेंज इन द टेम्परेचर, इंक्रीजेस एक्सपोनेंशियली विद इंक्रीज इन टेम्परेचर. सी ऑप्शन है डिक्रीजेस विद द इंक्रीज इन टेम्परेचर, और लास्ट ऑप्शन है इंक्रीजेस विद द इंक्रीज इन टेम्परेचर. तो अगर आपने सही से पढ़ा है देन बीटा and ICO increases as temperature increases, and the graph is, the beta is also called HFE or beta versus IC in microampere. So for 100 200 this curve look like that. This is for this, for this, so it is minus 25 degree, 55 degree and 125 degree. So beta and the reverse leakage current or the just leakage current increases as the temperature increases. So for this question the correct option is D. Clear? Next question देखते हैं. Now fifth और sixth question देखते हैं. The for linear, that is least distortion amplification purpose, the cutoff for the common emitter configuration is will be defined as by. So solution देखते हैं now. For common emitter the IC is what? It is beta IB plus 1 plus beta times ICBU, that is also equals to beta times IB plus ICU. Now in cutoff region the base current is 0, then the IC is only equals to ICEU, that is equals to 1 plus beta times of ICBU. क्लियर है यहाँ तक? So check करिए कौन सा ऑप्शन है. So IC equals to ICEU, IC equals to ICU is given in A option. Now the second option is for active region. It is for active region and these option are incorrect. So इस क्वेश्चन का जो करेक्ट आंसर होगा वो A करेक्ट होगा. नेक्स्ट क्वेश्चन है द ट्रांजिस्टर लीकेज करंट मेनली डिपेंड्स अपॉन doping of the base, size of the meter, rating of the transistor, and last one is temperature. Now if you see for common base, common emitter and common collector, this is ICBO, this is ICEO and it is gamma times ICBO. These are the currents, it is called leakage current. These are the leakage current which is due to thermally generated minority charge carriers. As temperature increases, it increases and for every 10 degree rise in temperature this current becomes double. क्लियर है? सो इस क्वेश्चन का जो करेक्ट आंसर होगा वो बिल्कुल सही क्या होगा? डी होगा. क्लियर है यहाँ तक? नेक्स्ट क्वेश्चन देखते हैं. नाउ 7th और 8th क्वेश्चंस देखते हैं. If alpha is 0.995 and I is 10 milliampere, ICO is this 0.5 microampere, then ICEO will be. So ICEO in common emitter is equals to 1 plus beta times of ICBO, or we can say ICO, either ICBO or ICO. ठीक है? So for calculating of ICO we require beta. No, but alpha is given, so beta is alpha 1 minus alpha. Then you calculate alpha 0.995 upon 1 minus 0.995 and it comes out to 199. Then ICEO is equals to what? 1 plus 199 into ICBO is how much? 0.5 into 10 to the power minus 6. So it is 200 into 0.5 into 10 to the power minus 6. So it is what? 200 into 0.5. So 5 to the 10. So 20. Just a minute. It is 1 into 10 to the power 2 into 10 to the power minus 6. Clear? So if you apply this thing, then it is 100 microampere. Is there any option? Let's check. So I think it is not 100 microampere because 5 to the 10, yeah, it's over. So it is 10 microampere. So it is 10 microampere. Is there any option of 10 microampere? So 10 microampere is given in C option. ठीक है? Next question है, what would be the value of IB for a properly biased transistor if it is given that IC is 10 milliampere and I is 10.2 milliampere. Now for any transistor, any BJT like NPN or PNP, the IE is equals to IB plus IC. From that IB is IE minus IC. So I is how much? 10.2 minus 10, that is 0.2 milliampere. Now 0.2 into 10 to the power minus 3. So I just multiplied by 1000 and divide by 1000. Is it okay with you? So 0.2 multiplied by 1000, that is 200, and this gives you minus 3 power add, so 10 की power minus 6, so it is 200 microampere. चेक करिए कोई ऑप्शन है 200 microampere का, या द डी ऑप्शन इज गिवन फॉर दिस क्वेश्चन. क्लियर है यहाँ तक? नेक्स्ट क्वेश्चन देखते हैं. नाउ 9th और 10th क्वेश्चन समझते हैं. इन ए बाइपोलर जंक्शन ट्रांजिस्टर विथ फॉरवर्ड करंट ट्रांसफर रेशियो द अल्फा is given, that is 0.98. When working in common emitter mode provides current transfer ratio beta. ठीक है बेटा यहाँ तक. Now if you remember the theory, the IE is equals to IB plus IC. Clear है यहाँ तक? Then just you take IC common, IE upon IC, that is 1 plus IB upon IC, then it is 1 by alpha, then it is 1 plus 1 by beta, that is equals to 1 plus beta upon beta. Clear है यहाँ तक? So alpha is beta upon 1 plus beta. Now from that just cross multiply 1 alpha plus alpha beta equals to beta, then alpha equals to beta minus alpha beta, and just take common beta and 1 minus alpha, then beta is equals to alpha 1 minus alpha. So you just put this value 0.98 upon 1 minus 0.98, then you get 49. So 49 is given in C option. ठीक है. Next, in a transistor beta express in terms of, so अभी हमने solve किया as below as, so beta is alpha 1 minus alpha. Check कर लीजिए एक बार, and you can have one more option. If you take minus common, then it is alpha minus 1. Clear है? So check कर लीजिए कौन सा ऑप्शन आपके सामने प्रेजेंट है. अल्फा 1 माइनस अल्फा इज प्रेजेंट इन ए ऑप्शन. तो इस क्वेश्चन का जो करेक्ट आंसर होगा वो ए बिल्कुल करेक्ट होगा. नेक्स्ट क्वेश्चन देखते हैं. 11th और 12th क्वेश्चन लेते हैं. विच ऑफ द फॉलोइंग रिप्रेजेंट द करेक्ट रिलेशनशिप बिटवीन द कलेक्टर टू इमीटर कट ऑफ करंट ICU ऑफ ए ट्रांजिस्टर and collector to base cutoff current, that is ICBO. ठीक है. We have to find the relation between the ICBO and ICU. ऑप्शन आपके सामने गिवन है. नाउ अगर मैं बात करता हूं यहाँ पर कॉमन, दिस ICEO is the reverse leakage current in common emitter configuration. Clear? So this ICEO is equals to 1 plus beta times of ICBO. Now what is the beta? Beta is what? 1 plus alpha 1 minus alpha ICBO. Then if you solve this value, then 1 minus alpha plus alpha 1 minus alpha into ICBO. Then this alpha to alpha cancel out, then the answer is 1 upon 1 minus alpha into ICBO. Clear है? So the relation between the common emitter leakage current and the common base leakage current is IC equals to 1 upon 1 minus alpha times ICBO. तो चेक करते हैं कौन सा ऑप्शन है. हमारे सामने एक ही ऑप्शन दिखाई दे रहा है, दैट इज सी. तो इस क्वेश्चन को जो करेक्ट आंसर होगा वो सी करेक्ट होगा. नेक्स्ट क्वेश्चन है. इन ए जर्मेनियम बीजेटी फॉर यूजुअल वैल्यू ऑफ द कलेक्टर करंट व्हाट इज द ऑर्डर ऑफ द ट्रांजिस्टर अल्फा. नाउ द अल्फा इज द कॉमन बेस करंट गेन where the alpha is defined as the ratio of IC upon IE. Now since IE is greater than IC, that's why the alpha is less than 1, and the range of alpha is 0.95 to 0.98. Clear है यहाँ तक? So alpha is less than 1, and this common base configuration provides alpha less than 1. That's why this configuration is not suitable to current amplifier. Clear है? Now alpha less than 1 is given in A option. For this question the correct answer is A. Now 13 and 14 question लेते हैं. In a transistor emitter current is 8 milliampere and alpha is 0.99. Then what is the collector current? So alpha is what? Alpha is IC upon IE. Then IC is equals to alpha times IE, and alpha is how much? 0.99. Then IE is what? IE is given to, that is 8 milliampere. So for this question the answer is 7.92 milliampere. Clear है? So बहुत सिंपल सा क्वेश्चन था. तो इस क्वेश्चन का जो आंसर होगा वो ए करेक्ट होगा. नाउ नेक्स्ट क्वेश्चन देखते हैं. ए ट्रांजिस्टर हैज द फॉलोइंग करंट. IB is 25 milliampere and IC is 4.975 milliampere. Then IE is then IE is according to the KCL in either NPN or PNP transistor, IE is equals to IB plus IC. So IB is how much? 25 milliampere plus 4.975 milliampere. So it is approximately equals to how much answer? 25 milliampere plus 4.975 milliampere. So if you add up, your answer IE is 5.225 ampere. क्लियर है यहाँ तक? सो ए ऑप्शन करेक्ट होगा. नाउ नेक्स्ट क्वेश्चन देखते हैं. नाउ 15 और 16 क्वेश्चन देखते हैं. द करंट गेन ऑफ ए कॉमन इमीटर ट्रांजिस्टर इज 50. दैट इज कॉमन emitter. So alpha is given to you, that is 50. The change in emitter current, then we have to find the change in emitter current for a corresponding change of base current of 5 milliampere. So base current is given to you, that is 5 milliampere. Now since alpha is IC upon IE, clear? Then IC is what? IC is what? Alpha times IE. Clear है यहाँ तक? So alpha is 50. So IC is how much? IC is alpha times I. Alpha is 50 and I is how much? Emitter current corresponding change of base current. ठीक है यहाँ तक? So I hope so. I is also equals to IB plus IC. गलत हो गया ये, फिर कटिंग करनी पड़ेगी, जल्दबाजी में ना. Now 15 और 16 क्वेश्चन देखते हैं. द करंट गेन ऑफ ए कॉमन इमीटर ट्रांजिस्टर इज 50. सो कॉमन इमीटर का अगर हम बात करें तो जो करंट गेन होता है दैट इज बीटा, दैट इज इक्वल्स टू IC अपॉन IB. क्लियर है? सो IC इक्वल्स टू बीटा टाइम्स ऑफ IB. So beta is 50 and then the change in emitter current for a corresponding change of 5 milliampere in the base current will be. So base current is how much? 50. So 5. So it is 250 milliampere. Now I is what? I is IB plus IC. So IB is 5 and IC is 250. So it's 255 milliampere. Clear? So 255 is in D. So इस क्वेश्चन का जो आंसर होगा D करेक्ट हो. Now ICBO in a transistor can be reduced by. Now ICBO is the leakage current. Is the leakage current which is temperature dependent. Which is temperature dependent. Clear? So this current can be minimized by using low temperature device. ठीक है? So D option is correct. Clear है यहाँ तक? Next question. Now 17 और 18 question देखते हैं. In the transistor, in a common emitter transistor circuit, if the current gain is 100, that is common emitter, so beta is 100. The collector current is 10 milliampere. Then the base current is, so beta is what? IC upon IB. So IB is IC upon beta. IC is 10 milliampere and how much is beta? It is 100. So 10, 1 by 10, that is 0.1 milliampere. So IB is 0.1 milliampere. Now 0.1 is not given, so 0.1 into 10 की power minus 3 divided by 1000 divided by 1000 multiplied by 1000 and multiplied by 1000. So it is just 1 microampere. Clear? So 1 microampere is given in any option. 1 nowhere is given. Let me correct one more time. IB is this. IB is IC. IC is how much? It is 10 milliampere. Let me check. 10 milliampere. Beta is 100. So 1 by 10. 1 by 10 means 0.1 milliampere. So 1000. So it is 100. Sorry, it is 100. It is 100 microampere. It is 100 microampere. So इस क्वेश्चन का जो आंसर होगा करेक्ट, बी करेक्ट होगा. नेक्स्ट क्वेश्चन देखते हैं. बीटा ऑफ ए ट्रांजिस्टर कैन एक्सीड. सो इफ यू सी द बीटा is a common emitter current gain. Alpha is always less than 1, that is common base. Beta is greater than 1 for common emitter. Gamma is always greater than 1 for common collector gain. Clear? So alpha is less than 1, beta is greater than 1, gamma is also greater than 1. क्लियर? सो इस क्वेश्चन का करेक्ट आंसर क्या मिलेगा आपको? ए मिलेगा। नेक्स्ट क्वेश्चन 19 क्वेश्चन और 20 क्वेश्चन देखते हैं। ए बाइपोलर ट्रांजिस्टर हैज अल्फा 0.98 ICO 10 माइक्रो एम्पियर। इफ द बेस करंट इज 100 माइक्रो एम्पियर देन कलेक्टर करंट वुड बी। ठीक है, सो इफ यू रिमेंबर द रिलेशन IC इक्वल्स टू बीटा IB प्लस 1 प्लस बीटा टाइम्स ऑफ ICU। ठीक है, नाउ अल्फा इज गिवन, सो बीटा इक्वल्स टू अल्फा 1 माइनस अल्फा। क्लियर है? When you put this value, alpha is how much? 0.98, 1 minus 0.98, and it comes out to be 49. So just put here 49 into IB is how much? IB is 100 microampere plus 50, that is 1 plus 49, 50 into how much? 10 microampere. Clear है यहाँ तक? So 49 and it is 49000 microampere plus 500 microampere. So if you add up this, then you get 5.49 milliampere. 5.49 milliampere. तो इस क्वेश्चन का जो आंसर करेक्ट होगा वो डी करेक्ट होगा। नेक्स्ट क्वेश्चन देखते हैं। फॉर ए BJT विच ऑफ द फॉलोइंग इज इनकरेक्ट? क्लियर है? सो इफ यू रिमेंबर द बीटा इज अल्फा 1 माइनस अल्फा, देन फ्रॉम दैट अल्फा इज बीटा 1 प्लस बीटा। क्लियर है? एंड the 1 by alpha upon 1 plus beta is 1, that is equals to 1 plus beta upon beta. So alpha is beta upon 1 plus beta. This is also true. So A correct, B correct, C correct. So the relation D is not correct. So इस क्वेश्चन का जो करेक्ट आंसर होगा वो बिल्कुल सही D होगा। D जो है वो इनकरेक्ट होगा। क्लियर है यहाँ तक?